Hi guys, if you have questions, email me or write a comment.
Today I'm going to talk about an interesting topic that exists in every branch of math. I'm going to talk about identity and inverse. Let me ask you this question. What is the identity of addition? Well, maybe you don't know the name, but you know how it's applicable in the operation. Let's say I want to apply 2 plus a number and I want the answer to be 2 again. I don't want any change on the number. Well, most of you will say that number should be 0 because 2 plus 0 will remain 2. Actually, this is the identity of addition. 0 will be the identity of addition because it does not change the value. So the identity means that the value remains the same without any changes. So identity of addition will be 0. Okay, do we have an identity for multiplication, for example? Identity of multiplication. Is there such an identity? Well, there is actually. The identity of multiplication, let's say 2 times what will remain 2. You will probably say 2 times 1 equals 2. So the identity of multiplication is 1. Is that all? Is it only for addition, multiplication? Well, actually, it exists in every branch in math, and I'm gonna move on later to show you that, to remind you that it exists in matrices and also in functions, which is a main topic. So let's now talk about the use of identity and why do we need it. Okay, let's say I wanna ask you this: 2 plus what will give you the identity? 2 plus what will give you the identity? It's 2 plus negative 2. Negative 2 here is called the inverse, the additive inverse. So the additive inverse of 2 is negative 2. Why is that? Because when you apply the operation, between the number and its inverse, you should get the identity. So in order to call something an inverse, it should satisfy this. The operation, when it's applied between the number and the inverse and the number, the answer should be the identity of that operation. So the inverse of addition will be the opposite sign of the number. In this case, 2 plus negative 2. So if I'm talking about negative 5, what's the inverse of negative 5? So I should ask myself, negative 5 plus what will give me the identity of addition? So it's negative 5 plus 5. So negative 5 and 5 are inverse of each other because when I apply the addition operation, that will give me the identity of addition, which is 0. What about multiplication? What's the inverse of 2? So I have to ask myself, 2 times what will give me the identity of multiplication? 2 times what will give me 1? Well, the answer of that is half. So in multiplication, the inverse is the reciprocal of the number. So 2 times half will give you 1. Another example for that, let's say 5. 5 times what? Times 1 over 5, because that will give you 1. Let's say 2 over 3. 2 over 3 times the reciprocal, 3 over 2, which will give you 1. So in addition, the inverse is the opposite sign. The inverse is opposite sign. In multiplication, the inverse is a reciprocal. And 1 over 2 over 3 will give you 3 over 2, of course. So, inverse and identity for now. Why do I need these? Let's say I'm asking you to solve an equation like 2x plus 5 equals 11. How am I going to solve this? Solve means find the value of x that satisfies this equation. So how am I going to isolate x? How am I going to keep x alone? Well, in order to do that, I have to make use of the identity and the inverse. The first thing to be done is to get rid of the 5 by adding its additive inverse. So by adding its additive inverse, what would I get? What's left for me? Here, I will be left with 2x plus the number and its identity should give me, the number and its inverse should give me the identity of addition, which is 0. And that will be equal to 11 plus -5, which is 6. Now, as we said, anything with the identity remains the same. So this is 2x equals 6. Now, the next point is to get rid of the 2. How am I going to get rid of the 2? Now, this is 2 times x. So I have to apply the inverse of multiplication. So I have to multiply by half, which is a multiplicative inverse of 2. Now, half times 2, this is 1x, which is equal to 6, and 1 times anything, it's an identity, so it will remain x only, so x equals 3. So actually we need the inverse and identity to be able to find the value of x when solving equations. Now, that's for equations. What about other topics? What is the identity of matrices, for example, a 2 by 2 matrix? If you finished, for example, studying algebra, you may find that there is a matrix, a 2 by 2 matrix, 1, 0, 0, 1, and that matrix is called the identity. Why is it called the identity again? Because if you apply the multiplication over matrices, if you multiply this matrix, this square matrix, by any other matrix, it will never change it. So it applies the definition of identity of multiplication. It does not change the operation. So identity for matrices is applied for multiplication, actually. Now, how would I find an inverse of matrix if I'm solving matrix equations? Well, let's say that we have a matrix A that's equal to 1, 2, 3, 5, for example. It has these values. How do we find the inverse? Well, there was a formula for inverse of matrices. It's 1 over the determinant of A times a new matrix that comes from the original one, which is just switching the places between diagonals, 5 and 1, switch places. So this will be 5, 1, and switch the signs of the other two values, so -2, -3. Now, what's the determinant? Determinant can be found by multiplying the diagonals and subtract them. So 1 times 5, so this is 1 over 1 times 5, which is 5, minus multiplication of the other diagonal, which is 2 times 3, that's 6, times this matrix, 5, -2, -3, and 1. 1 over 5 minus 6, that's -1. So we have -1 multiplied by all of these entries, which will give you -5, 2, 3, -1. This thing is the inverse matrix. Actually, we need to give it a name. How do we name an inverse? Well, I didn't write any name here. How do we name an inverse? So, in order to make things easy, we have decided to give it a symbol. So the symbol for inverse will be like the power of -1. This represents an inverse in general in math. This is not a power, this is just a symbol of the inverse. So A and A inverse. So this is A inverse. Let's check. Would that be correct? As we said, if you apply the operation between the inverse and the original, that should give you the identity. Is that correct? Let's check it. My inverse is negative 5, 2, 3, negative 1. Negative 5, 2, 3, negative 1. Multiplied by my original matrix, which is 1, 2, 3, 5. And let's multiply these two matrices. 2 by 2, 2 by 2, the answer will be 2 by 2. Let me remind you how to multiply matrices. You multiply the first row by the first column. So negative 5 times 1, that's negative 5, plus 3 times 2, that's 6, negative 5 plus 6, that's 1. And then you do the same thing. The first row by the second column will be here, the first row by the second column. So negative 5 times 2, that's negative 10. 2 times 5, that's 10. So that's 0. Same thing for the second row. 3 times 1, that's 3. Negative 1 times 3, that's 3. Negative 3, so 3 minus 3 is 0. Negative 1 times 2, 3 times 2, that's 6. Negative 1 times 5, that's negative 5. So 6 minus 5, that's 1, which is the identity. And actually that goes with the definition that we said about the inverse and identity. So same thing, the same concept applies also for matrices. Now the big question is, do we have an identity of functions? Is there a function that when you apply it, the values will never change? Actually, yes. Think about it. What about f of x equals x? Isn't that an identity? Let's check that. Check. F of 1, that's 1. F of 2, that's 2. So actually the identity of functions is x. The identity of functions in general is f of x equals x. So when I apply identity on functions, when I apply inverse of functions, I have to get the identity function, which is x. The question is, how would I find an inverse of a function? Let's say I have f of x equals 2x plus 1. How would I find an inverse function? And we are going to depend on the symbol that we used for matrices. Same thing, I'm going to use the inverse sign, which is like the power negative 1. And again, it's not a power, so I need to find f inverse of x and check that over the operations. F inverse of x. Well, how would I find f inverse of x? That's simple. I just need to solve for x the same way as we did with the linear equation here. Where is it? The linear equation, 2x plus 5 equals 11. So the same way, we need to get rid of the 5, we need to get rid of the 2 to keep it x alone. So let's apply the same steps. What will we get here? And as we know, f of x is equal to y, so it's easier for us to write it y equals 2x plus 1. Now if you're going to apply the inverse, so minus 1, this will be y minus 1 equals 2x. Now let's apply the inverse of multiplication. So this part times half, this part times half. What's left? What's left is y minus 1 over 2 equals 2 with 2 cancelled, so equals to x. So we have isolated x, and that is actually the inverse function. And since functions usually written as f of x, something that depends on x, so we need to write it in a better way. Instead of x, as I said, we are going to use the symbol of inverse. So this will be written as f inverse of x equals, and since it depends on x, so I cannot keep it written in terms of y, I have to make it x minus 1 equals 2. So my inverse function is x minus 1 equals 2. Now the big question is, when I apply the operation between functions f inverse and f, I should get the identity function, which is this one, x. Okay, what's the operation that should be applied here? Well, it will be the composition. So f inverse composite f of x, or in other words, f inverse of f of x. When I substitute f of x inside f inverse, or the opposite, f inverse inside f, will I get the identity function x? Let's check that. Let's work it out and see. F inverse of f, this means f inverse of 2x minus 1. So I'm going to substitute 2x minus 1 instead of this x here. What will happen? This will be, my function is x minus 1 over 2. So I have x minus 1 over 2, and I'm going to apply, the original function was 2x plus 1. So I'm going to apply this here. So let's substitute it. 2x plus 1 instead of this x. So it's x minus 1 over 2. So instead of this x, the purple one, I'm going to substitute 2x plus 1. And this is what I'm going to get. So let's simplify this. 2x plus 1 minus 1. If you notice here, plus 1 minus 1 will be cancelled. So we'll be left with 2x over 2. When you simplify that, you will get x. So actually, f inverse composite f of x gives you x itself. So no changes. When you apply the operation over the x stays the same. So we got the identity function of functions here, identity function of functions, which is x, and we were able to find the inverse function. Now, is that applicable for all functions? Actually, yes. If we have a one-to-one function, we can go for that in details, but I need this now to talk about trigonometric inverse. Let's say we have an example. We have sine x equals half, and I want to solve it. How am I going to solve this? How would I find the value of the angle x here? Well, we need to isolate it. How am I going to isolate sine x? Simply, we can depend on the same thing. We have sine x equals half. To get rid of the sine, that's a function, we need to apply what we have just said here, the inverse operation or the inverse function. So you will get sine inverse of sine x. Sine inverse also for this side of half. Now when you apply inverse on functions, these two will give you what? Only the identity, only x. F composite f inverse or f inverse composite f will give you only x. So on this side, you are left now with x only. Now sine inverse of half, this can be found by two ways, either by calculator, or this is a special angle, sine which angle is equal to half, that's 30 degrees, or in radian as it should be written, this is pi over 6. So x here is equal to pi over 6 if I'm talking about an angle in the first quadrant only. And of course, we can find general solution pi over 6. We can get more answers for that if we're looking for general solution. But if you're only applying sine inverse, that's what you will get, pi over x. I hope that you understand now what's meant by sine inverse, by inverse in general, where is it used.
Remember to like, share, and subscribe, and write your questions via email or comments.